Good morning, students. Welcome to physics class. Today we are going to study about the magnetic force. So in the last class you have already studied about the Ostwald experiment. When a conductor carrying a current, around that conductor there is a presence of what here? The magnetic field. And also you might have studied about the right hand thumb rule also. Now let us consider a Q is a charge. So here we have a Q is a charge. This experiences, it is kept in a water, the magnetic field. It is kept in a magnetic field. Let us say B. And that charge is the moving with the velocity, let us say V. V is a vector, so that's why we mention as the vector. If a Q is the kept, a moving charge Q, having a velocity what here? V, is a kept in a what here? The magnetic field. It experiences a what? The force. This is termed as a what here? Magnetic force. And just say Fm. When a charge is the kept in a what here? The magnetic field, that is B, it experiences a what here? The force. Then what is this direction of the force? Please apply the right hand thumb rule. This is the force is experienced here. And the velocity of the charge is in this direction. And the magnetic field is also in the same direction. So here, the F of M is nothing but what here? The magnetic force. Magnetic force. V is nothing but the velocity of the charge of the charge. And what is the Q here? The Q is charge. And B is nothing but a what here? The magnetic field. So with the help of this, how to give the force experienced by this charge? The force experienced is equal to the charge into what here? The velocity into the B, that is called as what here? The magnetic field. So this is what kind of a force here? That is nothing but a what here? The magnetic force. Therefore I can able to mention. So this is also a vector quantity. So F is equal to Q into V into what is that? B. Where the Q is the charge, V is considered as the velocity of the charge, the B is nothing but what? The magnetic field of it. Then what is the magnitude of that force? What is the magnitude of that force? The magnitude of the force, magnitude of magnetic force is nothing but a what here? F of M is equal to Q into V into B, that is sine theta. Equal to what here? Sine theta. This is what I can able to consider the magnitude of what? The force which is experienced by this the body. Now we have the several cases for this. Several cases. When the magnetic field and also the charge are parallel to like this, or it may be a perpendicular to like this, and if there is no velocity for the charge, then what happens? There are several cases. There are 4 cases of their cases. Let us study about the first case. Let us say here is a charge. A charge is moving in this direction. This is the direction of the charge. Then direction of the magnetic field. Magnetic field is in this direction. This is the magnetic field direction. B. It's a vector quantity. Both are moving in a what here? The parallel lines. Or in an anti-parallel. Anti-parallel means the one is moving like this, another one is moving in this manner. Or we can say the anti-parallel lines in this direction. Then what is the force which is an acting on this? Let us say the first case is like this. Q, the charge, and the magnetic field being parallel, or we can say anti-parallel. Anti-parallel. So apply this one. F is equal to what here? F is equal to, F of M is equal to Q into V into B sine theta. Then theta is equal to where? If theta is equal to, what happened to the theta? Theta becomes a 0, or it is equal to 180 degrees. 0, or I can even say 180 degrees. What is sine is 0. It is equal to 0. So therefore, f of m is equal to, that is equal to what happens here? There is no force which is an experienced on the what? Charge. There is no force which is an experienced on the charge. When these two are what here? Parallel or anti-parallel. There is no force. No force which is an experienced on the charge Q. Then what is the second case now? Second case. A charge Q and B. Charge Q and B is the what? The magnetic field are perpendicular or right angle to each other. You already know that right angle to each other means like this, Q, and also what is that? The P. The charge is the perpendicular to the water, the magnetic field. Perpendicular means theta becomes a what here? So F of M is equal to Q V N to B into what is that? Sine theta. Therefore, this becomes F of M is equal to, so here I can take it, Q is, theta is equal, if theta is equal to what happens here? 90 degrees. So therefore, the F M is equal to, what happens? Q into V into what is that? The B. Then it will become so what here? The force becomes what? Maximum force which happens. Maximum force becomes what? Maximum. Then if let us consider this is a positive charge like this, is moving in a positive, this is considered as what here? The plus. Then if it is a downwards means what happens here? It will become so what here? Minus. We consider this as a what here? Minus. Then if the theta is equal to F, a theta is equal to 270 degrees, then what happens? Then what happens? F of M is equal to Q into V into B, that is sine 270 degrees. What is sine 270 degrees? This becomes a minus. So therefore, I can able to say F of M is equal to minus of Q into V into what is that? B. It is always considered as what here? Negative. Force is becomes a what? Negative. Last case. Let us consider a last case here. What is the last case here? V is here. Okay, the V. This particular V, the velocity is not at all there. It is a static condition. It means that Q is just in a static condition. It is not moving at all. Then V is equal to 0. The last case is if V is equal to 0, then F of M is entirely is equal to what happens? 0. There is no force which is exerted on what here? A charge Q. So these are the 4 cases. These 4 cases are very, very important for your CET and also for a NEET. They are asking that if the magnetic field and also the Q is parallel, what happens? Then you can say just F is equal to 0. If it is a perpendicular, if it is 270 degree, if the velocity is equal to 0, then what happens? So this particular force, what we had studied here, okay, with the help of this, we can able to find out what is the unit of water, the magnetic field also. What is the unit of magnetic field? Let us understand the unit of this magnetic field. Okay. So let us go for understanding the magnetic field. You already know that F is equal to what is that? F is equal to Q into V into what is that? B. I want to B. So I can able to write like this: B is equal to F divided what is that? Q into V. Let us put the magnitude of the sine theta is here. This is all the vector quantity. This is also vector quantity. This is so the vector quantity. Now here is the sine theta. Sine theta. If theta is equal to 90 degrees. If theta is equal to 90 degrees, so then what happens? If theta is equal to 90 degrees, and the force which is then acting on the body is equal to on the charge is equal to 1, so therefore it becomes a 1 Newton. Then what Q is nothing but what here, the 1 Coulomb. Okay, it is also becomes a what here, the 1 Coulomb. Then what happens here? Okay. So it means that B is equal to what here? B is equal to F M divided by Q V. Therefore, I can able to say this is under Newton. Newton divided by this is Coulomb. This becomes what here, the meter per second. So we can able to say the Newton Coulomb per second. The Coulomb per second is nothing but a what here? I is nothing but a current. Therefore, we can able to say that Newton Coulomb per second is nothing but a what here? Ampere. The ampere into what is that? Meter. So therefore, I can able to say Newton per ampere per meter. So I can able to say like this: Newton per ampere per meter. So this is nothing but a what here? Tesla. A Tesla is the unit of what? The magnetic field. So this is all about the magnetic force and the unit for the water, the magnetic, the field. Thank you for watching the videos. Thank you very much.